Hello, everybody, and thanks for joining. I'm Matt Brown. I'm with One Technology. Today's webinar is going to cover Spot by NetApp, specifically controlling containerization costs with Spot for Kubernetes environments. So we're going to cover an overview of the technology and how it can be used to make your Kubernetes and container environments more efficient and cost effective. So with that, I'm going to hand it over to Sol Ritchie, who's going to be presenting on behalf of NetApp Spot.
Sorry, I was on mute. Hi, everybody. Hope everyone's having a good morning so far. Appreciate everybody hopping on. And yeah, like Matt said, we are all about optimizing your Kubernetes environments running in the cloud. Specifically, we look to shorten the amount of time and effort it takes for you to actually deploy your Kubernetes workloads into the cloud, and also once they're in there, to run them very cost efficiently, getting down to the unit compute efficiencies. And I look forward to kind of talking with you guys about that a little bit today. So I'm going to go ahead and get my presentation shared here. Let me know if everybody can see this.
Yep, Sol looks good.
Okay, excellent. So I'm going to preface this a little bit with some of the basics of the cloud economics, because I think that's important to talk about real quick. So obviously there's three main ways to purchase compute. That's going to be on demand, which is kind of the most reliable, viewed as the most reliable way of purchasing your cloud compute, but it's also going to be the most expensive. A lot of times organizations will use that obviously for certain workloads, or maybe early on in their cloud journey, and then they decide to start using reserve capacity. So reserve capacity obviously locks you in at a certain discount rate. This is going to get you a little bit of a savings off of on demand, but it does lock you into using that certain instance for either a 1 year or 3 year period. And then last but not least, obviously there's excess capacity. So in the AWS world, that's called a Spot instance. Azure calls it a Spot VM. GCP calls it an interruptible VM. The good news about that is that it's incredibly inexpensive. It gives you a chance to really take advantage of the discount that they provide, up to 90% off. But the challenge there is that it is also the SLA doesn't fit most production workloads. Because it's excess capacity, the cloud provider can kick you out at any moment. I think with AWS, you have about a 2.5 minute SLA. With Azure and GCP, it's about 30 seconds before you're kicked out of that instance type. Obviously, that does not make for a happy production workload. So that's what we have solved for here at Spot, is being able to automate the utilization of a combination of all of these instance types at the best possible cost. So at its core, what we do is we are an intermediary layer that provides automated, optimized infrastructure between your underlying cloud infrastructure and the applications. So we integrate in with your existing cloud environment, and we're able to provide a streamlined application-driven experience to your ultimate workloads, not having to go in and manually provision certain instance types, not having to budget for those instance types. We automate all of the work that goes into that. The ultimate goal, on top of delivering a really cost-efficient and stable compute environment, is we're obviously looking to spend time to take your existing continuous integration and continuous deployment pipeline, extend it into continuous optimization, so that you're not having to, once you've pushed your code out, you're not having to go back and right size your workloads. You're not having to make sure, hey, can I run this on a cheaper instance in another way. We're all focused on, through automation and through doing it at scale, being able to have all of these continuous optimization steps be automated and run at scale for your organization, lessening your organization's inputs on the ongoing infrastructure management, and being able to kind of take a step back and let the machines do the work, so to speak. So at the core of this technology, we have about 5.5 years we've been in business, and we've been using that entire time to aggregate data on the availability of Spot instances within the Spot market. So we are actually able to predict, I mentioned earlier, there's that like 2.5 minute in AWS or 30 seconds in Azure SLA for kicking you off of a Spot instance. So we actually will be able to predict as much as 15 minutes or even an hour ahead of time if a Spot instance is going to terminate. So this allows us to do a predictive rebalancing and do a graceful migration of workloads from one Spot instance to another and deliver a 4.9 of SLA. So this enables you to run your production workloads on Spot instances, and gives you the ability to solve for that SLA that I mentioned earlier about using Spot instances in your environment. So prime example is one of our favorite customers is Ticketmaster. They actually run their entire production workload on Spot. This allows them to take advantage of not only of real-time cost economics, but also be able to, if you think about what happened with the economy over the past year or so, probably nobody has gone to a concert recently. If they were, so therefore nobody's buying tickets through Ticketmaster, right? So if they were covering their workloads entirely through commitments, they would have been financially sunk by all this commitment plans that were consuming compute that they were paying for that they weren't actually consuming. So the fact they're able to run on Spot instances means that their architecture is able to scale up and scale down automatically based on demand, and always running on the most cost efficient compute size, so that way their infrastructure is automatically right sized to the actual real-time demand. So that's where some of the real benefits come from a kind of a business standpoint. So I spoke a little bit about our predictive rebalancing. So in a normal circumstance, if you're running on Spot instances, you might have an interruption, for instance. Again, you get kicked out of that instance and you have to wait for, not only do you have to find, say, hey, move this workload over to another instance, but also wait for that instance to spin up, which is obviously going to cause delays in the needed capacity that you actually have for your workloads. So because we're able to predict when these instances terminate, we're able to do actually a green-blue replacement strategy to be able to gracefully migrate that workload to an instance and maintain that level of your capacity throughout the entire workload's needs. And we're even able to fall back to on-demand or reserved instance capacity if there's just not enough of that Spot capacity available. So that really is how we drive the reliability within the platform. But there's a little bit more. There's a little bit more from the kind of the ongoing efficiency standpoint that we also layer into that. So traditionally running an application on an auto-scaling group, you might be scaling up 1 or maybe 2 instance types, which means that you're scaling using this same this kind of homogeneous same units of compute, which means you're ultimately going to end up over provisioning, because your chances are your workloads don't scale at the same unit that the instance size does. So by using Spot, you're able to layer in multiple different instance sizes to be able to deliver a seamless, reliable layer of compute without having to over provision by using just one instance type. So that way, not only are you consuming your compute at the best possible cost using Spot instances, but you're also not over provisioning your instances by having extra compute layered on top of extra compute. So it's by design an incredibly efficient system. So that's how we do it. So how do we do that? So that's kind of the underlying technology and the premise of what we do. We have a couple of different tools that solve each one of those needs. So our core product, kind of our flagship product, is Elastigroup. This is the foundation for most of what we do. This is going to be for any applications you have where you are running in a workload in an auto-scaling group. We can actually import those auto-scaling settings into Spot, so that you are actually able to start deploying your workloads directly into running on Spot instances. Today, the building on top of that specifically for containers, and this is going to be the main focus of today's discussion, obviously, is going to be Ocean, which runs on top of Elastigroup, but provides some of that unit economics that I was discussing a minute ago, with being able to mix multiple instance types. We actually provide some additional optimization specifically for containers. I'll speak about that more in a minute, but this is really intended to deliver a serverless infrastructure that is incredibly efficient and cost effective, specifically for your containerized workloads. Finally, there's Eco, which is a reserved commitment management platform. All this does is your typical process for doing some capacity planning might involve looking at a dashboard, pulling spreadsheets, sending that spreadsheet out to be reviewed by multiple department heads or team heads. So what Eco does is it measures your actual consumption of your existing RIs and your existing compute needs, and will actually automate the buying and selling of reserved instances, commitment plans, savings plans, convertible RIs, and we'll actually not only automate buying that, but there's actually a secondary market that Amazon runs where we actually will be able to broker that transaction. So if you have excess capacity on a reserved instance that you're not using anymore, we can actually sell that for you and regain some of your initial investment. So that's kind of how we've automated the budgeting for commitment plans process. And finally, last but not least, Cloud Analyzer is a cloud visibility tool that we have. This is a free product that we provide to our clients. The good news about this is that it's a good way of getting visibility into where your expenses are coming from inside your entire cloud environment. But where it differs from other tools that maybe just provide basic visibility, we are actually able to feed this into the rest of our tools to actually provide automation so that you're actually doing something about the visibility that you're getting. So it's not just an alert engine, it's actually feeds into the automation platform that we have in the rest of our portfolio. So again, that's the overall Spot story on sort of how we built what we built and how we're going to how we like to view optimization and capacity planning. We're going to focus a little bit more on Ocean today. So let me just skip ahead. The last thing I will say though is that one of the really nice things about working with Spot, aside from the fact that we're incredibly easy to set up, which I'll speak about in a little bit, we the way our fee system is based is that we actually only charge a small percentage of the overall discount that we deliver to you. So we take a measurement of what your compute costs are running on Spot and what you would have spent on using on-demand capacity, and that total amount of discount, we just keep a small percentage of that. So that's how there's no way that you would be able to spend more using Spot than not using Spot. We're completely focused on customer success. So that's the way we have that built out. Cool. I will go ahead and jump forward a little bit. So as we discussed, Ocean is going to be the primary focus of today's discussion. And because this focuses in on Kubernetes and running containerized workloads on a very, again, efficient, cost-efficient platform. So one of the nice things about Ocean is that we integrate in with your existing control plane. So whether you're using EKS, AKS, ECS, or even if you're running bare metal Kubernetes in your environment today, we would connect in via an API. And as your control plane deploys your worker nodes and pods, we actually will automate the underlying server or compute layer to run all of the nodes that you have. So again, all we focus on is the data plane, not anything to do with the control plane. So whatever control Kubernetes controller you're using today is going to be the exact same thing that you'd be able to continue using with Spot. So I spoke a little bit earlier about how we're really focused in on doing the running on Spot instances as best we can, and utilizing the best pricing model available for compute. That is the base layer of what we do with Ocean. So as your worker nodes and pods are deployed, we're able to provision the infrastructure to be able to actually run them. We'll make sure that we're buying it at the best possible price. We'll run it with a single layer of abstraction. We'll run a serverless experience for your worker nodes to then run on. It takes about 15 minutes to import. It's a very straightforward process. And again, it plugs into your existing control plane. But on top of that, we realized that there was some challenges with the ongoing management around actually running your containers on this type of an environment. So on top of that, I mentioned earlier mixing and matching a couple different instance types. So we will automatically bin pack or kind of like play a game of Tetris with your worker nodes and pods, and maybe you're running them normally on like an M5 medium. We might deploy a couple of them onto an M5 extra large, which we can get at a lower cost per vCPU. So you're actually taking advantage of some cost savings by combining a couple of different worker nodes on it to running on one instance type, again, because we're providing that layer of abstraction. So whereas you might see sort of lower, CPU utilization in a typical, running a typical Kubernetes workload on a regular instance type, you would actually see on our platform, you see CPU utilization over 90% for the entire stack. So that's going to be how we really make sure that you're not generating waste by provisioning sort of chunky, homogeneous instance types and generating waste that way. So, but that's still not quite enough as well. So another thing that we've done is we really like to focus in on right sizing the containers themselves. So we actually will study the behavior of your containers as they're running on our platform. After about a week of running on it, we will be able to make a recommendation back to you either through an automated container right sizing script, which we can provide you, or just as a notification back to you that, hey, you need to consider resizing this container, because if your programmers are trying to allocate a certain amount of capacity into their pods, they might, for instance, say, okay, we need to run 3 vCPUs to run this container. But if we've run it for a week and we notice it's not consuming more than 1 vCPU, that's where you're going to see waste generated. So the fact that we will monitor that, we will automatically make that recommendation back to you saying, hey, that you're actually provisioning extra waste into here. Another thing that we'll do is we will actually leave a certain amount of headroom on the compute, so that you have a little bit of wiggle room for a warm start to take place if you do have a spike in traffic. So that's something that we actually have a patent pending on, where you don't have to wait for spot instances or any instances to come online if you're seeing a spike in traffic. We actually accommodate for that automatically. So that's kind of the technology in a nutshell, and how we have built that out. I need to just give me just a second to switch, and I'll show you what the actual console looks like. So Matt, I don't know if we have any questions in the chat or anything like that that we need to ask real quick.
Does anybody have any questions? Use the Q&A there if you do. In the meantime, I'll monologue, so I'll just buy some time here. We'll fix it in post.
Yeah.
So, but yeah, if anyone has any questions, fire away. We'll get those answered now, and then at the end of the presentation as well. We should call on people. That'd be the cruel junior high moment where your name gets called and you panic. You weren't paying attention.
Sorry, everybody, bear with me 1 second. I managed to close the window that I needed, so I have to log back into a tool real quick.
No, just so everybody knows, Devontae from the One Tech team is harassing me right now, making fun of my bad dad jokes on our internal teams. So for anybody that's not on our teams, know that it's being taken care of. So Gary from the NetApp team wants to know, is Gary Martin Sol's favorite NetApp rep for New Mexico?
Absolutely, in New Mexico.
Good. It's a competitive field, I'm sure, right? The state you only get to choose 50 of your favorites. I'm sure David Watley wants to know if he's your favorite Department of Energy rep.
I love all of my colleagues equally.
Good.
Alrighty, I should be up and running here. Give me just a second.
I'm gonna bleep out all my jokes so it sounds like it was I just went on a tear of cursing, like just terrible language. I'm going to bleep every other word of your presentation, Sol, so you sound like you're a jerk.
That's fine. That's fine.
Good. Good. All right. Back to you.
All right, great. So I hope everybody can see my screen. So this is what the console looks like. This is how we built it out. It's very user-friendly. So you'll notice here on the side, we do have the products I was discussing earlier. And again, we're going to be focusing mostly on Ocean. So let me go ahead and just kind of click in here, show you guys what this looks like. So you'll see right off the bat, again, our focus is incredibly, we prioritize cost savings over almost everything else within our tools. So if you look in here, there's, we have on an ongoing basis, we're consistently measuring, okay, how much are you actually saving running on Spot? What is your total month to date saved? And where maybe are there cost overruns that you haven't addressed? So you can see this particular organization has been quite well optimized. We're only recognizing a small amount of missed opportunity to run on a more cost-effective unit of compute. Overall, we have quite a bit of ability to kind of measure where your clusters are performing and where you're seeing some of the cost overruns happening. So I do want to take a look at kind of what when we look at kind of what the clusters actually look like on an individual level. So let me just pull up one of these as well. So if you wanted to say drill down onto a certain cluster, this is going to be what it looks like. So you can see it's measuring your resource allocation for both CPU and memory. I mentioned earlier that we have headroom to allocate for warm starts, and so you can scale up, readily. And that's what you can see here, and that we have that kind of broken out on these two charts between your CPU and your memory. There's quite a bit of information on here of understanding, okay, what's my pod activity look like? What kind of capacity am I running on? See, for instance, this cluster is running entirely on Spot capacity, but we also have the ability to run on existing reserved instances that you have, or even fall back to on demand for any workloads that we feel that's the best choice for. Again, a lot of information in here. I did talk a lot about kind of what it looks like on the optimization at the actual compute level. So if you look here, I mentioned the bin packing. We have CPU utilization over 90% in almost every single instance, because we're bin packing multiple pods and containers onto one single instance type. That you're going to be able to take advantage of really consuming whatever compute is the best cost at that time. You'll see along here, there's several different sizes of instances. We're automatically provisioning that, so you don't have to go in and individually measure that yourself, decide, okay, can I combine these into a larger instance and save some money? All that's being taken place automatically. And again, you're seeing a resource allocation that is very, very high for so that you're not generating waste into that. So this is going to be where you're seeing, again, the consumption of compute being very, very efficient, very cost effective. And again, because they're running on Spot instances, not only are you having to use fewer instances because you're combining them, but the instances that you're actually running on are the most cost-effective ones out there. So that's how we're really able to take advantage of significant cost savings. I think that one of the common misconceptions that we run into is that sometimes people think, okay, this is just a product that runs my workloads on Spot instances within Azure AWS, and that's not the case. That's like saying that it's like saying that your car is just a set of wheels. That most people have some kind of affection for their vehicle, or they have chosen whichever one it is for a reason. So without getting too far down into a false comparison here. The idea is that not only are you being able to run your workloads on Spot instances, but you're actually able to, again, make sure those instances are being fully consumed and that you're not allocating waste into it. So that's kind of what it looks like within our tool here. So another thing I mentioned, obviously, is the right sizing. So, and of course I broke it, good job. Let me go back into another cluster and make sure that I can show this to you guys. Okay, looks like we might have a little bit of a glitch in the system here. Let me just pick one other one. Yeah, looks like this might be something I need to check with my tech team. But basically on this view, you would see actually at the pod level, you'd see the allocation of, okay, look, we have a vCPU allocated versus consumption, and we also have the same thing with memory. We have a strong preference for the memory, sorry, for the CPU consumption, because it's going to be a more expensive unit of compute within the cloud provider. So we really try to optimize on the compute versus the memory. But basically, that would be where we would see, okay, this individual container is running at again, it's been allocated for 3 vCPU, but you're not seeing consumption higher than 1 vCPU over the past week. So we'll actually be able to make that recommendation back to you. I actually had a client last week who had the opposite. They were having some problems within their pods that they hadn't quite diagnosed yet, where they were having some issues with the pods not running the way they were expecting it to. We plugged them into Ocean, and we were able to identify almost immediately that they had under allocated their memory that they needed to run the workload. So we were able to provide that immediate value back to them of like, hey, this is something you need to go in and you need to be able to upgrade so that your containers have enough room to run. So. And again, there's a bunch of other information here around cost analysis and being able to understand where your maybe where your largest chunks of your cloud bill are coming from, so you can really have an idea of your overall cloud economics. So that's how we built Ocean to be sort of a tool to automate and again optimize and really deliver a high degree of cost efficiency. So that's in a nutshell, that's the way that the product works and how we have it built out. Matt, do we have any other questions or anything in the chat?
Yeah, let me look real quick. We've got one. What does Spot's competitive landscape look like? Who else does what you guys do?
Good question. So the short answer is nobody does everything that we do. There are obviously there are native functionalities built into AWS and Azure that allow you to utilize Spot instances inside like a managed node group, for instance. There are tools that also provide right sizing recommendations back to your containers and everything. And there are also tools that will give you cost functionality like this, but nobody in the marketplace that I'm aware of is doing all of these things combined and also layering in the automation in with that. So sometimes we get compared to like, for instance, our Cloud Analyzer tool, which is useful for showing overall consumption. That gets compared to Cloud Health a lot. Cloud Health is a great product, and a lot of people use both Cloud Health and our platform to be able to provide detailed cost chargeback or whatever. But they don't provide the Cloud Health is a dashboard and a notification engine. They don't actually take the additional steps then to automate. And if you're allocating resources inefficiently, any delay of time is just going to be a waste of money. So again, there are other products that will be able to look at your containers and say, hey, this container is too big, this one's too small, and again, make recommendations back to you. But there isn't, as far as I know, nobody does that on an automated basis. And oh, by the way, also actually runs the underlying infrastructure. So I think the biggest hurdle that we run into sometimes is people will say, hey, this is great, let me see if I can build this myself. And that's great. But I would argue that as easy as we are to set up, I think I alluded to that a couple of times. There's my client who just joined us last week, we had their first Ocean cluster up and running inside of 30 minutes. And that included having to debug some custom namespace that they had set up. So the fact that you probably could build something like this yourself, but Spot takes about 15 to 30 minutes to set up, and that way you can get your containers running on a very cost-effective compute at scale very efficiently, very quickly. Means that kind of, why would you build your own, right? Like there's almost no reason to actually dedicate your resources to the infrastructure when you can just work with Spot, have us manage all that for you, and then run, and then you can get back to just building the technology that you're building. So. Hope that answers your question.
So I think that's perfect.
Okay, great. What else do we have? Any other questions?
Let me see. I think that's all we've got right now.
Okay.
Was there anything else, Sol, that you're covering?
No, I think that since the focus is on Ocean, I think that's going to be good for right now. Unless we want to kind of give people a few more minutes to ask final questions. Again, we're very easy to work with. And obviously, you know, we love working with One Technology, and we're very interested in learning about how your environment works and how we can make it better.
Awesome. Well, Sol, thanks for presenting today. Everyone, so you know, we'll be publishing this so that if there's other folks within your organization that want to see in the overview of Spot, we can do that. We'll also, Sol's available as well as the One Technology team for any follow-up if your team wants to dive into specifics. And then remember, from a pricing perspective, you know, Spot is compensated based on money saved. So there's no front end cost to it. You commit to deploying the technology, they save you X number of dollars, and a percentage of that pays for the Spot, but it's no front end transaction cost to your organization, which is really the cool part of Spot. So keep that in mind. And if anyone has any questions, let Sol and I know, and we'll call it a day. Thanks, everybody.
Thanks, you guys.
Thanks, Sol.
You bet.